right. So for covalent bonding, atoms share one or more electrons. Each atom is left with a complete outer shell. A covalent bond forms between two nonmetals. So the ionic bonds, metals over here with nonmetals over here, and covalent bonds are just the nonmetals. Now when I say nonmetals, it does include the lonely guy, hydrogen, way over here on the other side, because hydrogen's a gas. Okay, so we're going to do some covalent bonding. So clear your slate from ionic bonding. I do not want you to get the two mixed up. Okay, so we have hydrogen and hydrogen. Each hydrogen has how many valence electrons? 1. So I have 2 valence electrons that I'm going to be working with total here. Shh. We're doing this together. You have your own paper. Okay, we're learning as we go. So these right here up here, the 1, the E with the line, that's electron. Each of these have 1 valence electron, so I'm working with 2 total. So what I do for this hydrogen bond, I know these two are going to bond, right? I'm going to show you this. I don't expect you to get it after the first one. So what's happening here is these 2 hydrogens are sharing their 1 electron. It's like a Venn diagram, and they're sharing their electrons in the middle. And you have what molecule? What is it? H2. This is a diatomic molecule. It's just 2 hydrogen atoms bonded together. Remember that hydrogen only needs 2 valence electrons to be full. So if both of those hydrogens share their 1 with each other, then they both have 2. And that's a covalent bond they're sharing. They hold on to their bonds tightly to maintain the molecule. Okay, the next one, this one you're more familiar with. You have 2 hydrogens and 1 oxygen. What molecule are we going to make? H2O. Let's add up the valence electrons so we know what we have to work with. 2 hydrogens would be how many valence electrons total? 2. Oxygen is in group 16, so we have 6. So we are working with 8 valence electrons for this one. All right, whenever you have one element by itself, because this is 2 hydrogen and 1 oxygen, put the single guy in the middle. Okay. I know right away that those hydrogens are going to share electrons with the oxygen. So what I'm going to do is I'm going to do this right away. Because I know that they're going to be sharing electrons. I know it's a molecule. It's a covalent bond because it's 2 nonmetals. And what I'm going to do is go like this. I know, right? This is my Mickey Mouse water molecule, except the ears are on the side of the head instead of the top. All right, so I had 8 valence electrons. How many did I already use in my picture? I've already used 4, so I have 4 left. So what can I do with those 4 left that would also make oxygen happy? Because these 2 hydrogens are happy. They're full. They got their 2 now. So what do I do with the 4 that I have left that would give oxygen its 8 and make it happy also? Samantha? Make what again? I have 4 dots. What should I do with the 4 dots that would also make oxygen happy? 1, 2, 3, 4. So now look, oxygen has its 2. Hydrogen have their 2. And oxygen has its 8. 2, 4, 6, 8. That's why it's good to keep track of your valence electrons so you know how many you have left, and it gives you an idea of where you can put them. If you are completely lost, hang in there. If you mentally quit, then you shut down you're not going to pick it back up again. Okay, all I'm asking is that you follow along. All right, 2 chlorines. Each chlorine has how many valence electrons? 7 and 7. So I am going to be using 14 valence electrons. I know that chlorine is going to bond with chlorine. Okay, I know that these two are going to bond. How many electrons did I use? 2, so I have 12 left. What do you think I can do with the 12 that I have left that would make them both happy now? Ashley? How many on each side? 6 and 6. Kind of what I was listening for. 2, 4, 6, 2, 4, 6. Now they both have how many? 8, and they are both happy now. They are complete. They have their complete outer shells. All right, now I'm going to throw you a curveball. It had to come sometime. I know. So oxygen and oxygen. Oxygen is 6, so 6 and 6. We're going to be using 12 total. Let's bond. I used 2. I have 10 left. Right away, I always hear 5 and 5. But would 5 and 5 make them both have 8? No. So we have a problem. What could we do that has to do with sharing, since this is covalent, where we have 10 more electrons left, but we could make them both have 8? Has to do with sharing, and we can make them both have 8. This is called a double bond, where they're actually going to share 4. Now I have 6 left. And if I go yeah, that's where I'm confused. You're right. I only used 2 more. I confused myself. I was like, wait a second. Now I have 8 left because I had 12 and I used 4. I had 12 and I used 4. So I have 8 left. What do I do with the 8 that I have left? 4 and 4. So now look. 2, 4, 6, 8. 2, 4, 6, 8, because they're sharing 4. And they still have these 4 on both sides. So now they both have 8. And that's called a double bond. The formula is O2. This one that I forgot to do is what? Cl2. No more double bonds. There are triple bonds too. So if you ever do a double bond and it still doesn't work, it can be a triple bond. Okay, carbon and oxygen. Look, I have 1 carbon and 2 oxygen. Carbon has 4 valence electrons. Oxygen has 6. If I have 2 of them, there's 12. So I have to work with 16 valence electrons, 12 plus 4. I have a carbon and 2 oxygen. What did I say about the single guy? Put him in the middle. How many did I just use? 4. So I have 12 left. Now, would 6 and 6 make them all happy? Look, guys, watch this. I put 6 on this side, and then if I put 6 on this side, would it make them all happy? Why not? Carbon would only have 4 instead of 8. So, what do you think the solution's going to be for that issue? So, I just used 4 more. So, I have 8 left. So, 1, 2, 3, 4, 5, 6, 7, 8. And I have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And what's my formula? CO2, this is carbon dioxide. So carbon is sharing all of its electrons, and oxygen is only sharing how many? So they're sharing, oxygen is sharing 4, and carbon is actually sharing all of its electrons, and it's finished. Okay, I really like this last one. I know you're saying, I'm sure you do. But we have a tendency to do things like this. It's carbon and 4 hydrogens. We have a tendency to want to go like this. But the reason we can't do this is because if we bond these, can hydrogen have that many valence electrons? No, because it can only hold 2 in its energy level. Does anyone remember how carbon goes in the middle because it's by itself? Can anyone give me a solution to that dilemma, Brenda? You can. I can go like this. Look, guys. I am done. Everybody's happy. How many does carbon have? 8. How many do all the hydrogens have? 2. So look. I have to do these. These are just fun to show. Okay, what's my formula? CH4. And those are covalent bonds, and that's when you have nonmetals bonding with nonmetals.